Chapter 5 Coordination Compounds. Transition metal complexes, ligands, neutral molecules or ions that have lone pair of electrons that can be used to form bond to metal. Lewis base is electron pair donor, metal Lewis acid, electron pair acceptor. Metal can accept more than one ligand, which is a Lewis base. M is a metal and L is a ligand bond, coordinate covalent bond between metal and ligands. Lewis acid base adopt formation. Transition metal complexes coordinate covalent bond. Both electrons in shared pair come from same atom. This is the example. So this one cation and this is the lone pair. So the lone pair here will share with the cation. So we'll form this one. Coordination complexes, central metal atom surrounded by set of ligands. This is the example of the complex ion and the coordination compound. Complex ions of nickel 2, look at this, left green and the right one is blue. Left green, nickel 2 with 6 water ligands, and this is the example of the complex compound. And for the right, blue, nickel 2 with 1 water and 5 amine ligands, and this is the example of the complex compound. Formulas of complex ion. The symbol for the metal ion is always given first, followed by ligands. When more than one kind of ligand is present, so the ionic ligands are first in alphabetical order. Neutral ligands are next in alphabetical order. Charge on complex is algebraic, sum of charge on metal ion and charge on ligands. The formula is flashed inside of square brackets with the charge of the complex as a superscript outside the brackets if it is not 0. Example, cobalt 2 with 6 water molecule and 2 the chlorine ion. Ligands, the 6 water molecules are bound to the cobalt 2 ion. Counter ions, the 2 Cl, meaning that the 2 chlorine ions are there only to balance the charge electrical neutrality. This is the table for some common ligands. And this is the example of monodentate ligands, meaning that only one Lewis base. So this is the example of the monodentate ligands. For the bidentate ligands, they have 2 as the Lewis pairs. And this is the example of the polydentate ligands, more than 2. Metal complex nomenclature. IPAC rules for naming coordination compounds. First, cation name first, then anion. Names of ionic ligands always end in suffix O. For example, chloride, so the ligand is chloro. So for the bromide, the ligand bromo, and cyanide is cyano, and the oxide is oxo. Ligands whose names end in IDE have suffix changed to O. Metal complex nomenclature rules for naming coordination compounds. Ligands whose names end in ITE or ATE become ITO and ATO. For the ATE, ATO, and ITE, ITO, respectively. And when you look at the anion, carbonate, the ligand is carbonato. For the thiosulfate, thiosulfato, and thiocyanate, thiocyanato, when bonded through sulfur. Isothiocyanato, when bonded through nitrogen. And oxalate, oxalato, and for the nitrate is a nitrito, when bonded through oxygen, written ONO. And the formula for the complex. For the nitrate, if nitro, when bonded through nitrogen, it is an exception. So this is also the example for the ligands and also the formula. And this is also the ionic ligand and also the neutral ligand. For the amine is a NH3 and H2O is aqua, NO nitrosyl, CO is the carbonyl, and O2 is dioxygen, and 2 is dinitrogen, and this is the ethylene diamine, and this is the 3-phenylphosphine, and this is the pyridine. Okay, for the neutral, when you look at the end of the name, it's not the O. Okay, for example, amine is not amino, it's still amine. And when you look at the ionic ligand, the ligand is the Br negative. We know this is the bromide. So the name is bromo, meaning that the suffix change with O at the end of the word. Okay, so we know this is the ionic, meaning that they have a charge. Depends on the ion. So here, O and O is the oxygen bonded, meaning that the nitrito. If the NO2 negative one is N bonded, so this is the nitro. So for the SCN, S bonded is the thiocyanato, and for the N bonded is isothiocyanato. So this one have the negative one. This is also the example for the cation and anion counter ion. Metal complex nomenclature. Neutral ligands given same name as used for molecule except H2O water is aqua, we not use the water, and the ammonia NH3 as amine. When there is more than one of a given ligand, specify number of ligands by prefix. Number of same ligand 2, 3, 4, 5, 6. So we know simple ligand prefix for 2 is a di, 3 is the tri, and 4 is tetra, 5 penta, and 6 hexa. Complicated ligand prefix is for the bidentate or polydentate. So this is the 2 is bis and 3 tris and 4 is tetra case. Metal complex and nomenclature, ordering of ligands in formula, symbol of metal first followed by ligands. Ligands order, ionic ligands first in alphabetical order, neutral ligands next also in alphabetical order. In the name of the complex, ligands named first in alphabetical order without regard to charge. Metal name last. Nomenclature. If the complex ion has a negative charge, the suffix ate is added to the name of the metal. Okay, so we look at this. The negative charge meaning that is the ionic. So we look at the metal aluminium. So the name in ionic complex is aluminate, and chromium is chromate, manganese is manganate, nickel as the nickelate, and cobalt is cobaltate, zinc zincate, and platinum platinate, and vanadium is vanadate. This is the example for the nomenclature. Okay, for example, is the 1A, dicyanoargentate 1 ion. Okay, the first one, how you do it?